It's actually my first presentation at the user group in Sydney, or in Australia to be in particular. As one might hear from my accent, I'm not a native speaker. I'm from Germany, so relatively far away, like 20 hours of flight, so takes a bit of time. And yes, I'm going to introduce you a little bit to event storming, not too mixed up with event sourcing. That is a technology that's interesting, but not necessarily related. Maybe it's going to get you to use that if you do this a little bit more, but we'll see. So I have roughly 50 minutes officially. We'll see if I manage, because originally those sets of slides was planned for like a 45 minutes talk. So I threw out a bunch of slides, but I didn't have much time to check because officially I'm on vacation. My wife already hates me for being here. So a quick introduction anyhow. So
please feel free to put all the blame on me.
Will do.
Please.
Okay, so quick introduction anyhow. So that's me. I'm, as I already said, from Germany, together with my two colleagues. Everybody who's using PHP at least probably knows Sebastian Bergman, who is one of our co-founders as well. So I work with him on a day-to-day basis. So that's why we all like testing, and obviously we use PHP Unit for the majority of things. We have clients around the world helping them on writing PHP software, not actually writing the software for them, but advising them on how to write what we consider proper software, how to do the right software, and not just software in the right way. Those things are important, and we try to help our clients, as I said, all around the world. Actually, I have no idea what the legal requirements would be to do that in Australia. But in most of Europe and the US, and actually Sebastian has been in Australia like 2 or 3 years ago for like a conference tour. So there are obviously ways to get us over. So if you have need for any kind of consulting work in that regard, feel free to reach out. Otherwise, we're here to speak about event storming, and well, that's enough marketing for now. Okay, so why do we need something like event storming? And as maybe some people read the abstract that I wrote together real quick. It's to understand what we actually have to do, right? I mean, we learned a lot of things on how to write proper software, as in what we consider to be technical standards on how to create software, like object-oriented and like certain design patterns to use and all kinds of things, which is all cool, but it doesn't help if it's the wrong software that you create in the end. So one of the key things to realize, and maybe that's obvious, but sometimes it's like stating the obvious is eye-opening for many people, so that's why I say it anyhow. Software is a means to automate a solution to a problem. As I said, it seems obvious, but maybe it's not, because understanding the actual problem is harder than it may seem. The biggest problem with that is that most of the time you get Jira tickets, like add this column to whatever kind of report, and well, easy enough to do, but you have no idea why you do that. So can you add an additional field to the database? Sure, that's easy. I mean, that's alter table, maybe takes some hours or weeks or years until the table update is done, but technically that's easy to do. But did it make the world better? Did it make the software better? Did it actually solve a problem the user had? Or was the user telling you the solution to a problem that he didn't even mention, or she for that matter? So with the domain-driven design things, obviously you want to go away from this purely technical thing. And if a normal user tells you to change something in the database, that means that you already violated basic ideas of domain-driven design because they started to adopt your language. It should be the other way around. So obviously, in this kind of situation, we ended up with a technical requirement given by a user, not helping. So what the inventor of event storming once said, and I think even wrote in his book, is working code is a side effect. So if the user knows about the code, if we as developers, even though we obviously get paid to create that particular piece of code, produce code, that's all good, but everything up front, everything before actually writing the software is even more important. Sounds weird if you are like paid to actually type things, but to me, that's the distinction between a typist and an actual programmer. Coming up with a solution, understanding the problem, and then deciding that this needs to be automated is, of course, a step that can be done at some point, but it's something that requires understanding of the problem. And the funny thing is we had various clients where everybody was 100% certain we have to create software for a certain type of problem. And just to give you that very example, it was a startup. They didn't have anything running yet, right? They just started like, hey, we have this cool business idea. And of course, we have to be able to handle if customers send the product back. So yeah, we have to design this process, so they have to refund, and we have to check if the product can be sold again. And they came up with a really complicated kind of things of processes and had many people arguing about it. And at some point, I don't know why, they decided to involve us, like, hey, help us in designing things and deciding on how to do stuff, because we're not sure we're doing the right thing here. So we sat with them and joined one of those meetings where like this sending back process was discussed. And the first question, in this case, my colleague asked, like, okay, so how many items did you sell already? Well, 0, you're not online yet. Okay, so how likely is it that people are going to send stuff back? Well, not really, right? Okay, so why are we designing a process for something we don't even know is going to happen? Because if you're not going to sell anything, it's not going to come back. Can we focus on actually creating the software that sells stuff? And if we sell 100 items, chances are, in worst case, 100 items will be sent back to us. Do we need software to handle this kind of thing? Or can this be done manually? Well, maybe manually is good enough. So that's not write software per se just because we can. So we have to understand the problem and the process and whether or not it's actually worth writing software for it. To do that, and to understand what we actually have to create and what the process might look like, we can use something that's called event storming. So the idea of event storming is to gather knowledge, to learn, and to model a process based on our collaborative understanding of this thing cross borders. Cross borders means not having the silos of like, here's the development team, here's the QA team, here's the actual user, and here's somebody else. Everybody who might be involved in this particular process will join. Sounds like really chaotic, but it's really powerful because you get really cool insights. And every time we do this at our clients, we sometimes get people involved that everybody else was like, but why them? Well, because they are part of your company and they are part of the process. So for example, we had an e-commerce retailer in Switzerland in that case of one of our clients. And we asked like 2 or 3 people from the logistics department to join our session. Like, why? They're just going to send out the package. Yeah, but they have to suffer all the crap that you accept on the website. So maybe you ask what they have as a problem so you can make the software actually do what they need to make their work better. And turns out a lot of things that they were annoyed with made perfect sense once they understood why it is that way. And quite a few things were easy to fix. Just we had to come up with a way of communicating and understanding and learning how the process is from all angles, from all aspects. So again, event storming is the key factor to get everybody on the same page. And the reason why we need a mechanism like this is pretty much resembled in this picture. So assuming that the majority of people in here are going to have a driving license, if I were to ask you to describe to me how you drive a car, I bet you would pretty much skip 90% of the things you're actually doing because they are natural, it's just part of your work. It's like, most of the people say like, yeah, well, you know, I enter the car, start the engine and drive. Well, what does driving actually mean? And did you open the door or jump through the window or how did you enter the car? Yeah, do you have a key or the engine just magically goes on or you flip a switch or what do you do? It's impossible to create software based on this very description. And it's impossible for you to realize that you missed out all the things because you're not knowingly skipping them. You're just like assuming that this is what everybody would understand, or that's so natural to you that it's an automatism to you. I mean, nobody is remembering to actually breathe. It's just something you do. So you can't really speak about it. So how does event storming work? Well, first of all, we need modeling space. That means a lot of white wall, particularly with paper on, so you can put sticky notes on. All this stuff is based on sticky notes. And I just brought a set of samples, and for everybody who's sitting close enough can actually see that. I'm going to throw those around. Yep. So the most important thing is to have sticky notes in various colors, and I'm going to explain the individual colors in a second. The most important thing is from this modeling space is it's what's seemingly unlimited. So quite many offices in a meeting room have like a nice flip chart. That's the opposite of unlimited. Because if you imagine a flip chart, maybe like a size like this is rather limited space. So if you're trying to model something, you want to have space in all directions, mostly on the terms of timeline. So if I put something in the middle, there's not really much space on either side. So you're psychologically restricted to the space and think all kinds of things are unimportant because they're not going to fit. So to avoid that, you want to have a somewhat unlimited space. So we need more of that. Sometimes you even have more in the other dimension, so you're going to have 2 rows behind it. And what we actually do sometimes, or most of the cases even, is to use, with those stickies, is actually to go to IKEA and buy mala, like those drawing paper for kids. That's cheap as it can get, and it's like a long, endless line. It's like 30 meters or so. That's a good space. And this is at a conference in Belgium. So, yep, that's sort of getting there, was his reply to that question. And as you can already see, there's like orange and blue stickies on there. So let's have a look at that. If you read the book, I'm going to have a slide on the book from Alberto Manrique, the inventor of event storming, at the end. There are various types of event storming. I personally find the process modeling the most important. And depending on where you are, it's either 2 Ls or 1 L. So I'm not really sure what kind of... those are fine here? Okay.
No, absolutely not.
I was trying to figure out which is the correct spelling here, but I didn't get very far. Okay, so we need this modeling space, and then we need domain events. And domain events are orange stickies, and this one may or may not see, those are like those small ones. And the cool thing is that those are to represent something that has happened. And as an event is something that has happened, it cannot be undone. You can have the counter thing or create something that negates that result, but it has happened. You have to deal with that. And what you do in the beginning is you collect all the events that you consider relevant to this particular process. That means, of course, not like the mouse has moved or something. That's maybe interesting if you're a browser vendor. But if you're modeling a certain type of process, all the things that actually are relevant to this particular process. And it doesn't matter what order. You just get them and put them around and like write it down, put it on. So everybody in the room, remember we invited everybody who might be involved into the process somehow, and just everybody gets written down stuff, puts it on, next thing, next thing, next thing. You're going to have a shitload of, sorry the words, of stickies that are orange, and obviously there will be a lot of duplicates. But it's important to realize that they are duplicates, and you might have different words meaning the same thing. So somebody said user, the other said customer. So now it's the perfect time to decide, are we talking about users or talking about customers? Are they the same? Or does the user turn into a customer? So finding out the correct terms so that everybody agrees on the actual language. So everybody who's into domain design, the ubiquitous language thing, there it is. So you're going to find out there are various things that you can sort. Some things you can trash, and you realize when discussing it, oh, actually we forgot this thing, this is also important. The next thing you do is start sorting it and forcing the timeline. So this has to happen, then this has to happen, then this has to happen, or this had to have happened, so this can happen, and so on. So you actually have it in a long, more or less horizontal row or line. And there might be things in parallel. So this might be one path, this might be another path. So you're going to enter having colorful ribbons in between. This is also like a paper thing. You can just put it in, and it's important to be paper, so you can actually really easily tear it over. And small and thin, that's varsity tape if you are into like what kids do these days, into books and things. So it's really all paper, so it's easy to remove and trash and to replace. So it just works quickly without any user interface, kind of computer complicated thing that you actually have to learn. It's all handwork and manual interaction. Since we had this like modeling space on the wall, obviously we're gonna have no chairs or tables or anything in the way, because if you're gonna be sitting down, you're gonna be out of the discussion. Sitting down means I'm out, right? I'm sitting here, and it's a lot of effort to actually get back up. You wanna be involved. So no chairs, maybe for a break later, but not while the actual session. So once you have that all sorted, we're going to have the opposite. We have to have commands, which basically means, like in this case, the blue stickies, and the color codes are not necessarily that important. It's just like what Alberto Nini once defined, and that pretty much everybody adheres to, but technically you could use any color you want. But again, the majority of people use those colors for a reason, so that makes sense that everybody knows, okay, if it's blue, it's this kind of thing, but you can redefine it as you have to, depending on what colors you get. And those things are actually printed by ourselves, so we actually have them with words on, so we don't have to look up the colors all the time or tell people again. So the command is the opposite to an event. As you can imagine, it's a user-initiated action. It's imperative, so tells like, do this. Easy enough. So now you have a pair of two things, which basically means this can fail, right? I mean, I can tell the system to do this, and it can refuse for whatever reason it might do so. Or there might be various results coming from this. So in most cases, it's going to be a one-to-one relation. You're going to have a command that will emit an event at the result. But sometimes there are two different events, or there might be error messages or whatever kind of things coming up from that. And you have the thing in the middle, as in something that actually handles the command. This is originally called aggregate. I'm starting to actually like this term less and less. I'm probably going to replace it for the next iteration with just domain logic, because aggregate sounds like relatively big, and it doesn't actually have to be big. So the aggregate is something that handles the commands and creates the events. So if you send a command to this aggregate or to this domain logic thing, it will decide whether or not it can do it, or wants to do it, or has all the prerequisites in place to actually allow to do it, and then emits the event with whatever kind of information required for that particular thing. Alternatively, if it's not something you directly want to talk to, there might be a policy which is reacting to events. Remember, commands being sent to the yellow box. So it's actually something you enforce, hey, do this. And once something happened, then obviously this line of processing has to continue. So you have a policy which will react to this. So it will handle a domain event. It will trigger additional things. And is often found at domain boundaries to tell others that something has happened so they can start doing whatever they want to do. And we have external systems. External systems sounds relatively complex, but it's everything external to the current domain. So the best example is, and I just gave a training like last week on event storming and process modeling in particular, where we modeled the checkout process of a fictitious startup. And people realized that, okay, if we're going to send out an item, we're going to need an address. So we need customers to register. Well, cool, but is the registration a process on its own, or is that part of the checkout? So looking at the checkout perspective, the only thing the checkout cares about is actually having the address. Where that address comes from is completely unimportant to this particular piece of process. So we decided from the checkout perspective, say, okay, we're going to talk to an external system, hey, register or whatever to give me that address, and just wait for it to be there. So that made that particular checkout process rather simple and small. Of course, for a working piece of software, that is going to be required, but it's completely open on where this address comes from. Obviously, to make decisions wherever we are, we're going to need data. And in case anybody heard the term CQRS before, this is directly where we're heading at. So we're going to need read models or data projections, depending on what terminology you prefer. It's something that you can use to look up stuff. And most important, even though I used a lot of terms here that are based on technology, they are, except maybe for like aggregate, if you replace that with domain logic or business logic, it's so abstracted away from technology that every non-technical person can really understand what this is. An event is something that has happened. That's easy. Every programmer sees like, yeah, this is an object with properties and I can query stuff. Awesome, but it's all details I don't really care about. This is something that has happened. It has a name. It's something that we all agree on what this actually logically means, but it's easy enough to actually be used. So if we combine this, and this is a drawing stolen from this introducing event storming book. So you have a command which is invoked on an aggregate, which then, as a result, creates a domain event. Then that will probably lead to whatever kind of read model being updated, which can be represented by an UI. And so a user can invoke a new command, and we are back at the beginning. Or we're going to send the command to an external system, which then, as a result, will generate the domain. And obviously, this means that not the system itself will do that, but the resulting code talking to the external system will actually deal with that. We'll generate this domain event, and then we have the same kind of thing again. Or we can have a policy, listen on this event, and either update a read model or issue new commands so things can happen again. So what may look like relatively confusing, if you start with those things that are relevant to the domain and just follow the individual steps, it's really, really easy to model a process and understand what's happening. We are talking on a very high level thing here in the beginning, but we can see a process going to be working. And we realize, okay, to make that decision here, I'm gonna need data. So I'm gonna add read models like crazy. And the cool thing is that this particular code or this particular code is really, really small because it only has to make a certain decision based on the information and based on the command that's being come in. So if you model software like this, this is an easy to understand process. Everybody who's involved in that particular business process can understand the process and can say something about it because, hey, we know to have this happening, we have to have this command being sent. So actually, this code gonna need this data. And it's really easy to grasp how this kind of thing that you're trying to develop or that already existed as a process and you never understood why the software works the way it does or is not working or why things are breaking at some areas. This is really easy to and clear to understand, and everybody speaks on the same terms because it's all named based on things that are actually relevant to this particular domain. So with this, we can model the individual steps. And what we can do next, and I don't have slides for that, is to take one of those things and say, okay, we're going to write software for this particular piece. And wherever that might be in the process, the only thing that you need to take care of is decide together with like the actual user, okay, what kind of information am I going to get here? What additional information or rules do I have to have here? What rules do I have to implement here? And if it works, this is the event that's going to come out of it. And I can write this as a small isolated piece of code. Obviously, we are communicating via events and commands. So you can replace this particular block by a different implementation without causing any big disruptions, because this is the command that if you cause this, or if a policy triggers this, or if a different piece of software now executes that, doesn't really matter. And of course, this is not defining on how the software is supposed to be written. If you use message queues in between or command queues, if you directly call this, it's completely up to you to decide what architecture to actually use. But as mentioned before, if you do this with event things, chances are you're going to end up in a CQF-like system, and chances are that you're going to use event sourcing at some point to persist all that stuff. But that's optional. The most important thing to realize is that if you have an event, you can react to this, have a policy to handle that, and update all kinds of UI elements. Or you can have code that actually does this synchronously. So whenever this happens, directly handle this, update projections, whatever you want to do. It's really small pieces of software. And to me, and so far to all the clients that ended deciding up using this kind of thing to model stuff, software development became a lot easier. It's really powerful. Once you do this, it needs some training, as in doing this over and over again to actually not get sidetracked in discussions too much, but actually focus on getting this process done. So maybe having an external facilitator kind of person coming along is a good idea. Marketing start, we can do this, marketing end. But it really helps to get an understanding and then decide, okay, once we have this, and that can actually take a day to fully model this out, so we actually have a full understanding, everybody agrees, yeah, this is a process that works, or this is how the process currently works, and this is where we want to do changes. It's really, really powerful and simple in the end. Then to understand this is the full thing, so we know this is working, we have an understood problem, we have an understood process, now we can start implementing the individual things. And I had a session like a month ago or so at one of our clients where a person working for like 2 years for that company, after the session said, you know what, I finally understand what we are doing and how we're doing it. Because obviously nobody has the means of explaining all the details because you simply don't know what you do. As I mentioned, this is the book. I'm not getting any marketing money for that, but it's a really cool book. It's, I think, 80% or so complete. It's a lean thing by Alberto Vanolini, the Italian guy who invented this. There's also the other types of event storming explained. There are various training events that you can get. There's domain-driven design conferences that apply this as sessions. There's a Canadian company, actually, they call it event modeling. This is pretty much close to the process design that they just showed. And they have the fun thing that they actually do this with their clients to write software for their clients and say, every orange sticky is $2,000.
That's a nice approach.
And if you model it this way, it's easy enough. Yeah, it helps to decide, do I actually need to automate this problem? Or that solution, rather, to that problem. And then, okay, this is the things you can do. And of course, there will be things that take longer and other things that will be easier. But on average, that probably works pretty well. Thank you very much.